Good evening to all. This is Engineering Mathematics 2 and this is 5th unit Laplace transforms. Okay, so now we are going to see the 5th unit, that is Laplace transforms. This is 5th unit. So we already know that first and second unit. The third unit is analytic functions and fourth unit is complex integration. So for the third and fourth unit, we already know that what is complex number, how to add two complex numbers, how to subtract, how to find the integration. So we already know about some basic ideas and formulas we already know. But in this unit, we don't know about the basics also. So first one, definition for the Laplace transform. See, this is unit name Laplace transforms. Okay. So first one, definition for the Laplace transforms. Okay, so one function f of t. So one function f of t, that function in terms of the variable t. So now we can find the Laplace transform of f of t. Here capital L denotes the Laplace transform and also this can be denoted as capital F of s. So now we are going to see the definition for Laplace transform. That is nothing but integral over 0 to infinity e power minus st f of t dt. Okay, so this is the basic definition for the Laplace transform, that is L of f of t, that is nothing but Laplace transform of f of t, that is equal to f of s, that is equal to integral over 0 to infinity e power minus st f of t dt. Okay, so next one, definition for the exponential order. Definition for the exponential order. So one function f of t, when this function is said to be of exponential order. Okay, this is the definition for when the function f of t is said to be of exponential order if it satisfies one condition, that is limit t tends to infinity e power minus st f of t. Suppose that is equal to 0 means we can say your function f of t is said to be of exponential order. Okay, so next one, example. So one function t square is of exponential order. So we have to show that function t square is of exponential order. So we already know that when one f of t is said to be of exponential order, if limit t tends to infinity e power minus st f of t, that is equal to 0 means we can say f of t is exponential order. Okay, so here one function t square. So here we have to show that the t square is of exponential order. So first we have to find this limit value, and if it is 0 means we can say t square is of exponential order. So what is the condition? Limit t tends to infinity e power minus st f of t. So in this problem we have to show that function t square is of exponential order. So limit t tends to infinity e power minus st. Here what is your f of t? That is t square. Okay, so that is equal to limit t tends to infinity t square. This e power minus st can be written as in the denominator e power st. So now apply the limit t tends to infinity. So numerator, that is infinity, divided by e power infinity is infinity. Okay, so now this is in indeterminate form. So we can use the L'Hospital rule. So L'Hospital rule is nothing but apply the same limit t tends to infinity, but differentiating the numerator, that is 2t, divided by and differentiating the denominator, that is s into e power st. So now apply the limit. So in numerator again that is infinity, denominator that is e power infinity infinity. So again that is of the form infinity by infinity, that is indeterminate form. If it is indeterminate form means we can use L'Hospital rule. So again same limit t tends to infinity. So now what is the differentiation value for numerator? 2t means that is 2 divided by s into e power st means s square into e power st. So now apply the limit t tends to infinity. So 2 divided by e power infinity infinity. So 2 by infinity is 0. So now our limit value t tends to infinity e power minus st function value t square that is equal to 0. So we can say t square is of exponential order. This is 2 mark question. Okay. So next we are going to see the basic formulas. Okay. So that is we are going to see the Laplace transform of the basic functions. Laplace transform of sin at, cos at, e power at, e power minus at, etc. Okay. So first one, Laplace transform of 1. Okay, what is the meaning? Laplace transform of 1 that is equal to 1 by s. These are all basic formulas. So second one, L of cos at. So cos at is equal to s by s square plus a square. So third one, L of sin at that is equal to a by s square plus a square. So fourth one, L of e power at that is equal to 1 by s minus a. Fifth one, L of e power minus at that is 1 by s plus a. If it is a means s minus a means 1 by s plus a. So next one, Laplace transform of hyperbolic functions. Cos h at that is equal to s by cos at means s by s square plus a square. Cos h at means s by s square minus a square. Seventh one, L of sin h at that is equal to a by s square minus a square. So last formula, L of t power n. So that is equal to n factorial. Here n is nothing but that is the power divided by s power n plus 1. Okay, this is the formula for Laplace transform of t power n that is equal to n factorial by s power n plus 1. So these are the basic formulas. By using these formulas, we can attend the 2 mark questions in this unit. So first problem, find the Laplace transform of f of t. The f of t is f of t is 3 into e power 5t plus 5 cos t plus t cube. So one function f of t is given. We have to find L of f of t. That is nothing but Laplace transform of f of t. So L of, what is your f of t? 3 into e power 5t plus 5 cos t plus t cube. So that is equal to, here there are 3 terms. So we can split into 3 terms. So first term is 3 into e power 5t plus Laplace transform of 5 cos t plus Laplace transform of t cube. So that is equal to, if there is any constants, we can take into outside. So 3 into L of e power 5t plus 5 into L of cos t plus L of t cube. So that is equal to 3 into, we already know that one formula. What is L of e power at? That is 1 by s minus a. This is of the form L of e power at. Here a value is 5. So 1 by s minus 5 plus 5 into L of cos t. So what is the formula for L of cos at? This s by s square plus a square. So now this is cos t. So here a value is 1. So by using that formula, you can write s by s square plus a square is 1 plus, by using the last formula, L of t power n is equal to n factorial by s power n plus 1. This is of the form L of t power n. Here n is nothing but 3. So by using that formula, we can write 3 factorial by s power 3 plus 1. So that is equal to 3 divided by s minus 5 plus 5s by s square plus 1 plus 3 factorial is 6, 3 plus 1 is 4. So now this is the final value for the Laplace transform of the given function f of t. So that is the answer. So these are all 2-mark problems. So by using these formulas, we can attend the 2-mark problems in this unit. Okay. So second one, L of second problem, L of sine square 3t. Okay. So we already know some formula. Sine square t is equal to 1 minus cos 2t by 2. Here this is of the form L of sine 80, but here this is sine square. So we can use the alternate formulas. We can write sine square t is equal to 1 minus cos 2t by 2. So L of sine square 3t, that is equal to L of, we know that sine square t formula, that is 1 minus cos 2t by 2. So sine square 3t. So here t means here that is 3t. So 1 minus cos 60 by 2. So here 1 by 2 is constant. So we can take into outside L of 1 minus L of cos ht. That is equal to 1 by 2. L of 1 is 1 by s. By using first formula, L of 1 is 1 by s. So 1 by s minus cos 80. So cos 80 means s by s square plus a square. So here we can write s by s square plus a square is 36. Here a is 6. Okay. So that is the final answer. So L of sine square 3t is equal to 1 by 2s minus s by 2 into s square plus 36. That is the final answer. I multiply the 2 into both terms. So next problem, when f of t is given, that is cos square 2t. Okay, find L of f of t. So one function f of t is given, we have to find L of f of t, that is equal to L of, what is f of t? Cos square 2t. If it is cos 80 means we can use the formula s by s square plus a square, but this is cos square 2t. So same previous problem. So is there any formula? Cos square 2t is not, cos square t can be written as 1 plus cos 2t by 2. So by using this formula, we can write 1 plus cos square t means 1 plus cos 2t divided by 2. So here this is 2t. Okay. So instead of t, we have to write 2t. So 1 plus cos 4t by 2. So that is equal to L of 1 by 2 is constant. So we can take into outside. So we can split into two terms. So first one is L of 1 plus L of cos 4t. So that is equal to 1 by 2. L of 1 is 1 by s. This L of cos 4t is s by s square plus 16. That is the final answer. Okay, this is the value for Laplace transform of that given f of t. That is the answer. So fourth problem. Find L of sine 3t sine 4t. So if it is sine 3t plus sine 4t means we can split into two terms. So by using that formula L of sine 80, we can find the answer directly. But this is of the form sine A sine B. This is of the form sine A sine B. So what is the formula for sine A sine B? Here we can write that is cos A minus B minus cos A plus B divided by 2. So by using this formula, we can split into two terms. So L of, I take this is A, this is B. So now this is of the form sin A, sin B. So L of sin 3t, sin 4t can be written as cos. Here I take that A is 4t. So 4t minus 3t, t minus cos 4t plus 3t is 70 divided by 2. applied Laplace transform. Okay, so 1 by 2 is constant, we can take into outside. So first one, L of cos t minus L of cos 7t, that is equal to 1 by 2. L of cos at means s by s square plus a square. So s by s square plus area is 1. So minus L of cos 7t is s by s square plus 49. So that is the answer. Okay. So similarly, by using this four formulas, sin A, sin B, sin A cos B, cos A cos B, cos A sin B. So similarly, by using these formulas, we can find the Laplace transform for L of sin A sin B, cos A cos B, sin A cos B, cos A sin B. Okay. So next one.